Hello, everyone. Thank you for joining today's webinar, where we will be discussing the latest developments in marketing measurement. My name is Marcel van der Kooi. I'm the CEO of ScanmarQED, and I will be your moderator today. We have an exciting program ahead. We will be discussing a new approach to marketing mix modeling, one that will allow teams to work with multiple engines and methodologies simultaneously, all in a seamless workflow. We'll start today with a brief overview first of the evolution of marketing mix modeling, and also describe how we ended or arrived in the current landscape and fragmented landscape of many solutions that are out there in the market. We will discuss the pros and cons of the various approaches, and we will also show why a multi-engine approach is a good approach and a step forward. We will also introduce MMM Labs, our new multi-engine solution that is really able to combine the different approaches. And finally, at the end, there will be time for Q&A. So we really encourage everyone to submit your questions, and we will do our best to answer them as best as we can. We will be discussing all of this with a great team of experts from the ScanmarQED side. We have Brian Cusick, who's leading our North American office. We have Phil Spencer, who's leading our UK office. We have Marieke de Koning. She is our lead product lead for the whole group. And we have Gabriel Mohana. He is ex-Amazon lead data scientist. He's the founder of MMM Labs, and currently he is our SVP AI at ScanmarQED. And finally, I'm also proud to announce our guest speaker, which is Professor Dr. Koen Pauwels. He's a distinguished professor of marketing at Northeastern University, and he's really a leading expert in media effectiveness research. And his work has been published in many journals, leading journals around the globe. Also important to mention is that Koen is a co-founder of MMM Labs, and together with Gabriel, their goal has been to really make marketing mix modeling accessible and impactful for marketeers. So welcome, Koen. I'm happy that you are with us today. And with that, let's get started. I want to hand it over to Brian.
Hi, everyone. We're not starting with a history to bore you. We're starting with a history because we really feel like our new platform is an evolution of the industry, and we want to give some background to set some context. When we look back at the early days of MMM back in the 1980s and 90s, was really an expert-only analysis, right? It was mainly the big CPGs of the world, like Kraft and Coke and P&G, fairly limited exposure, and the firms helping with this were truly niche providers. But as we move forward in time, get into the 2000s, 2010s, became a growing field with a lot of cross-industry adoption. Restaurants, retail, financial services kind of followed the big spenders in the paid media world. Started to become internalized by the larger media agencies and by the big consulting firms. A lot of the competition between vendors was largely about proprietary methods. And during this period of time, MMM was also trying to survive the rise of MTA. Digital attribution was very popular and growing, and MMM kind of hung on as a similar but different analysis. Now, as we move forward into 2015-ish, we saw a different kind of growth. The data science evolution brought a lot more modelers, and it brought a much broader toolkit. And we'll talk a little bit more about methodological changes in a second. But in a way, MMM now started to benefit from cookie deprecation and privacy concerns. Uh, and as it grew and expanded into more industries, the priorities started to shift towards process and business benefit and a little bit less, away from model fit and methods.
If I may interrupt here, Brian, and so Gabriel and I, we witnessed the shift also within Amazon, right? In our case, indeed. So with a lot of the kind of MTA approaches, you have sometimes a very deep understanding, but very limited. It's almost like a horse with the with the sidebars on, right? So MMM gives you that broad exposure that you can also model things that mass media, other things that your consumers might be exposed to, that you just don't have the identifying data for, or where privacy, either ethical or legal considerations, just less and less give you the opportunity. So that was indeed a key resurgence of MMM and a blending of the benefits of both approaches.
Yeah. So, on to current day, 25, 26. I mean, we see more brands and more industries than ever seeking out this type of marketing measurement. But I think the most interesting development really is this blurring of the line between in-house and outsource. Open source packages are of course part of that, but it's bigger than just where the code comes from. It's really rethinking, the best way to get this done. All right, so hopefully that's helpful context, but enough about kind of the business side of the industry. I think next we want to recap a little bit about how the methods have changed over time.
And yeah, so by training I'm an econometrician. I have a whole bookshelf here behind me filled with such books. And so when I entered the let's say the business, right, the whole focus was on econometric specification and trying to get everything just right, which works great in theory. In practice, that was not exactly the best way to go about, because it didn't work backwards, as I always say, from the decision maker's perspective. And what do you make a decision of? What are your constraints? How fast do you want the output also? And so originally also in my career, data was a differentiator. So we got better data sets, we got panel data sets, we got store level, market level, by account groups, by segments. And so that was really kind of the big differentiator in terms of also my academic work, but also of a lot of consultancy firms. Beyond that, we saw a lot of wonderful influx from Bayesian statistics that really helped to shrink some of the more kind of outrageous estimates that wouldn't be workable in practice for, let's say, some stores into an overall kind of average, depending on your prior expectations. It also really helped with missing data. So suppose your product is taken off the market, God forbid, for a while. Bayesian statistics could very well deal with that one. And of course, with machine learning, we got kind of a shift from pure explanation towards let's just predict for the sake of it, and be just much more flexible in terms of functional form, and just have a lot more interesting correlations emerge that we didn't have to talk about. It also went very much, against the standard MMM shortcomings. So MMMs used to take a lot of time to develop and to fine tune to really be workable for your business. These were very often in annual reports that people love to use maybe for a post-mortem evaluation about, hey, what was our ROI, what went wrong, what can we do better next year strategically, but didn't really allow you to adjust things on the fly, steering the boat as you're going through the storm. And of course, MMM was very much influenced, as I said, by MTA. And it basically, MTA raised expectations in terms of how fast you as a manager wanted to feedback, how granular you wanted it, and basically kind of how these frequent updates help you to steer the ship or the campaign, in this case, while it was ongoing. And of course, my first book was all about dashboards and how to make them work together. And this integration in your decision architecture was also a very big benefit that we got in the last years. So question for you is, where does it leave us?
That's a very good question, and the current MMM landscape is extremely complicated. So according to the latest measure map from Marketing Science Today, which you can see on the screen, there are now at least 65 professional solutions providers out there. And that's really a mix of traditional consultancies, of SaaS platforms, and hybrid players who combine some mix of the software and services. And this doesn't even count media agencies who have some of the biggest modeling teams out there. So it's a complex space. On top of that, open source packages are growing really fast amongst those teams that are comfortable writing their own code. So with so many different options out there to navigate, how should you go about trying to make sense of this? So the truth is that there are lots of different dimensions to think about, and actually mapping out those options is quite a complex task. But broadly speaking, we think these could be bucketed into three main groups. And you can think of these as three sequential questions, essentially. So the first of those is the strategic fit. So what kind of MMM capability are you actually looking to build? And this defines the operating model overall. And there are a few dimensions within this. So firstly, internal versus external. So do you want to actually own that capability or to buy it in? Ad hoc versus always on. So is this a periodic exercise? So the annual kind of approach that Professor Koen mentioned, or is it more of a live decision-making tool that's going to be used constantly throughout the year? And the third is people versus platform. So are you investing in human expertise or in software infrastructure? And related to that, to what degree is it fully automated process versus actually having humans that are in control? The second bucket is commercial and governance. So once you've answered the strategic question, you've got some practical questions about how do you actually control it and how do you pay for it? So open source versus proprietary is a topic that we'll dive into in a moment, but who actually owns the code? And if you want to modify it, is that something that's possible? On a commercial model, are you paying for subscriptions or consulting time, or is it actually free at the point of use? And then really importantly, transparency. So to what degree is it a glass box versus a black box? And can your team actually see and challenge what's going on inside? The third and final bucket here is then the methodology. So what does it actually do technically under the hood? And there are quite a few dimensions here. So a big one is complexity versus interpretability. So it's possible to build some extremely complex models, but more sophisticated models aren't always better. So actually being able to clearly interpret and understand what's going on and then make them actionable is crucially important. Frequentis versus Bayesian is a big dimension that's a debate in the industry. Professor mentioned some of the benefits of Bayesian, and we'll dive into this. And then we have various choices about the specific model structure as well. So is it linear versus multiplicative? Do we have pooled or nested or hierarchical models? And do the coefficients change over time, or are they static? So there are lots of methodological choices, but the really important thing I think to point out is that there's no universally best method. And actually the best approach to take really depends on what question you're trying to answer. And it only really matters if it gets acted on in practice as well, eventually as well. So it's a common mistake to jump, I think, too early to the methodology before deciding on what type of capability it is that you're actually trying to build. So get clear on that strategy question first. And one of the most consequential strategic choices that kind of combines a few of these things, has real implications across these buckets, is the question of enterprise versus open source. So I'll hand over to Gabriel to go a bit deeper on that topic.
Thank you, Phil. So, I grew up in the 2000s. Actually, before we start, there's a poll. What type of methods do you use? What method are you familiar with? Go ahead and take the poll. And I'll talk about that slide as you put your answers in. I started with MMM in the 2010, and it was all enterprise. Every company I went to, every vendor, they had their own proprietary method, and they basically promised structure structure mostly in scalability, but also comes with a lock-in. The code can be changed by the customers because it belongs to a vendor, and the vendor cannot change the code without passing the IP to the customer. And I always thought to myself, is there a better way? So open source started around 2015, 2018. Started with Robyn. Actually, PyMC existed at the time, but it wasn't very well known because it was very Bayesian. And very hard to understand. And then Meridian just came about in 2000, just last year. And they had a predecessor before that wasn't really, it was by Google, but it wasn't supported. And it was always my dream that, like, if we have a method, can we compare it to another? Does it say the same conclusion? It was extremely hard to do because it required at least additional 3 months of working with an additional team, with additional costs, and nobody wanted to pick up that. But now it's all different, and Marika can talk to you about this.
Yeah. So thanks, Gabriel, and let me introduce you to what is multi-engine marketing mix modeling, because that's also in the title of this webinar, and I think it's important to explain the concept. So very briefly, it's actually running multiple MMM engines side by side in one workflow. And Gabriel just talked about the trade-offs between the structure and the scalability of enterprise solutions and the flexibility and innovation of open source. And what multi-engine MMM allows you to do is actually it gives you the best of both worlds. So you don't have to choose in a way. So how does it work? There's 3 elements to it. As you can see on the slide, the first one is it starts all with a standardized data set. So you create a standardized form for your data, and then once you have that, you can actually feed it into multiple engines and run multiple engines at the same time. So how you can accomplish that is that, of course, you need to have these engines wired up at the back end, right, to your data set. But that is something that's done once, and then you can simply run these engines all in one go. And the engines you can include are the typical ones, so can be classical OLS, constrained OLS, can also be the open source packages, or it could be your own custom modeling approach. So if you've developed something in-house, you could also compare it side by side to open source packages. And then the third step would be that you would, in the same way that you have a standardized data set, you also have a standardized output. So you create one overview where you compare the models side by side, the engines, and you really see like how are they comparing to each other, how are they performing, which methodology is working best. So you can pick the winner, or you can choose a combination of approaches. So that is what multi-engine MMM is. So what are the benefits? So we see 3 main benefits. The first one is you will get better and more reliable models. And one of the main reasons is that trying out these different modeling philosophies in one go makes it very easy to try them out and get the different perspectives. Also, because you do that, you can have multiple people in your team actually work together. They speak the same language. They can see all the results and have a discussion. So that's how you get to better models. A second element is the flexibility and the avoiding of lock-in that you get. So the flexibility, what you can imagine, if you have all these engines available, you can just pick the best one for your situation. So you don't need to choose, right? Right now, you may be able to force to choose one because of the people you have available, the skills you have, what you tried before. If you use a multi-engine approach, you can simply try all and select the best one that works best for your business question. Also, you avoid a lock-in. And that's nowadays, I think, very important. We just saw the history of MMM and the development of all the methodologies. If you have all these engines available, you can very simply swap in a new one. And I think, Gabriel, you just mentioned all these open source packages. I think the one Google had earlier was lightweight. Yeah, it was a big thing a couple of years ago. Nobody's using it right now. So avoiding that lock-in is quite crucial for companies.
Yeah, I wanted to jump in on that because so I have seen companies locked in and the results were disastrous. So it's very similar. I always say to the stock market that everybody follows the same approach, right? And then the situation changes and the whole stock market crashes. So even if you have carefully selected one approach, don't just stick to it for 10, 15, 20 years, no matter what happens. There are a lot of changes in the market, competition, the broader macro environment, as we have experienced a lot in just the last 5 or 6 years. So being able to compare approaches and to also see, hey, maybe some of them are better for certain, new constraints that have come up is very important. Just like in the academic world, we constantly have to compare our model with other models to make sure that there's some basis in reality and that we give the best recommendations. So also in practice, kind of thinking like a scientist and being able to compare these different approaches side by side continues to be very important.
And actually, yeah, regarding the best approach, you don't know if you have the best unless you have looked at other options. And if you're locked into one model, you don't know. And the other thing is that every single model is wrong, a little bit wrong, but you don't know which one is less wrong than the other unless you've actually looked. And this is what we're providing with the multi-engine approach.
Yeah. No, I think these are all really good points. So thanks, Professor Pauwels and Gabriel. I think that's very important. And the good thing, Gabriel, to your point, all models are wrong, so let's try them all. So I think the third benefit actually is the efficiency and the infrastructure. So it's actually very easy to get started. If you've got this multi-engine approach set up, you can get started in a couple of minutes. You have this one standard data set that you need to prepare. But then after that, it's a couple of clicks and you get to your model. So there's also no code expertise needed, which is normally the case, right? If you want to try a new, especially these open source packages require a lot of setup to get started. And the last one in that area is that you do not need to worry about performance and infrastructure. So the people that have tried Meridian, PyMC, they will probably know or recognize that they can take hours, right, to run if you don't set them up properly, or you might need a bigger machine. All of this with a multi-engine approach, these things are already solved at the back end, so you can just run it and go without worrying about it. So with that, we have a good overview of what multi-engine marketing mix modeling actually is and what are the benefits. And I think Gabriel's actually quite excited to show it to you in action. So Gabriel, over to you.
Thank you. So here we talk about, now we're showing the multi-engine approach. It gives you real choices. So what I'm going to do is walk you through how we ingest the data, make sure it's standardized and harmonized, so that way it is available for all the models. And then we'll walk into some details of what we do in modeling. So the first thing is this platform is built so you can manage multiple different projects. So what is a project? So if you're an agency, you can think of it as this is a project for your clients. And so instead of relying on different folders and you don't know where on different computers of different people, it is all set in one place. If you are a brand, you might have multiple brands that you're doing this analysis for. So we provide you consistency to manage all of them. The data setup is easy. You can upload multiple Excel files, multiple different sheets. Every Excel file may have different tabs within them. We're also working on data connectors to different platforms. So what we do is that we auto-categorize this for you. We take the hard part. We identify the date sections. We make sure the metrics are correct. If you have channels, dimensions, sales channels, that's all auto-categorized and grouped by an AI system that we've built. So all you do is simply look at the results and say, all right, did the spend columns get correctly identified? The impression columns, the click columns, the revenues, the prices, external factors, are they all there and grouped correctly? And if you are a data scientist or if you're an MMM practitioner, you probably know how hard that part is. That would probably take you a few hours, sometimes days to get it right. And then if you got it right, next step is, how does it look? So we provide you some trend analysis, summaries, so you can share this with your stakeholders. And the goal over here is get the data right from the get-go and be able to share it with the business folks. As a data scientist, I can look at this and say, this looks right. But a business person might say, yeah, there was something missing somewhere in this week that we've had a promotion. And with this view, you can look at a summary of results. You can look at it from a sales perspective. You can look at it from media perspective to see are impressions matching with spend, or is there some discrepancy happening over here? So for a Google search, like how come we keep having, are we spending 0 every other weekend or not? A data scientist might look at this and say, this looks right. There's a trend here. But a business person goes, no, actually, maybe we were spending on the weekend. And maybe the business person might be surprised as well. And so the goal over here is to enable the data scientists or the marketing performance analyst or the MMM person to share this data with their stakeholders. And by the way, there's a sharing capability, so you can share this across teams. So it's not a single person workflow. The next thing is you go into your different configurations. Once you want to start the modeling process, we show you all the variables that are available in your data. And you can model it with spend, you can model it with impressions, GRPs, all these options are available. And one of the most powerful idea is to allow the idea of priors. Now, this is a very complex idea, mostly for the data scientists, and we've simplified it so that way a person can put their knowledge into the models. So they might say this variable needs to be positive. And not only positive, it needs to be within specific distribution. We've simplified it as we have defaults for the user. But if you are a Bayesian data scientist and you want to look at different distributions, you want to look at different adstocks function, different saturation functions, within a few clicks, we already have them. And all the models that we have will take advantage of them. Some models actually are built without any transformations, which is fine. But the models that take advantage of them will pick up on these priors, and they all work in a seamless fashion. Last few steps, you run all the models. It's as simple as run all models, and we can run OLS, constrained OLS. We have a proprietary one called adaptive MMM. We have Robyn, PyMC, and Meridian. And here is the idea, is that you can have some simple models to start with, like an OLS model, and you can compare them to a really complex model, like maybe PyMC or Meridian. And then you can compare the results. And if you have your own model, we can work with you to make sure that this capability is available. And I'm pretty sure a lot of companies are very proud of their models. But it requires lots of people to get this model to run. And what we oftentimes notice is that if you're an agency and you're developing an MMM model, you're going to rely on the person who's available with the knowledge that this person has to run a particular model. Well, that's no longer the case over here. You can run all of them all the time. Last few slides before we open up to questions. Here is what I call the money slide. This is where we actually compare the models from a both business perspective, like ad spend, contributions, and ROIs, to statistical perspective. Well, which one really is the best model from a predictive accuracy? And we're not only looking at a fitted training accuracy, we're testing each model to see how well it does on a data it hasn't seen. And like from my experience in marketing mix modeling, that last step is never done. You know why? Because it requires training the model twice. That means I have to lock my computer for a few more hours for that thing to run, for me to get the results. And it's spinning the entire time. I can't do anything with it. So it's oftentimes skipped. This example, we see PyMC has 99% accuracy. And this is not to say PyMC is always the best. Sometimes Robyn is better. Sometimes adaptive MMM is better. But what we're showing over here is where the models agree, where the models don't agree. Is like on this example, in the contribution, you see adaptive MMM says ROI of 11. PyMC and Robyn around 10, also 11, or Robyn was 10. And the simple models, if you're using simple models, say the ROI is 6. So the agreement over here is that the complex model more or less agree on the overall ROI, and the simple models have a much lower ROI. So you as an advertiser now, you need to decide which one do you choose. Do you go with the simple models or do you go with the complex models? And well, which one? We can even dive in further by looking at a comparison. Now, this is a little hard to see, But one of the things I realized right away is Facebook impressions between Meridian, PyMC, and Adaptive MMM were around $11 to $16. And I look at the second line on Google, and I noticed that Meridian said the ROI was 13, but the other two models said the ROI is close to 5. Now, I'm not saying Meridian said Google search as higher all the time, as in they're looking at the variable names, because this is a common mistake. I think Brian one time ran a model and said the Robyn model from Facebook said Facebook had 0 impact, like literally 0. And I looked at the code. That's what I do all day long. It is not looking at the variable name. It does not know which one is Facebook or not. As a matter of fact, we don't give it the exact variable names. There is some kind of a obfuscation that we do. At the bottom, the variables matched. So out of home, print, and spend more or less were on the same ROI. And so very quickly, as somebody using this, I'd go, well, I'm probably going to use somewhere between PyMC or Adaptive MMM. That can give me overall agreement between the ROIs, even on the channel level. And then we can look at Meridian down the road. Maybe it was correct. Here's what I would say. These models are going to give you a recommendation. And they're going to say, spend this amount on this channel in the following sequence. That recommendation could be correct or could be wrong. You as an advertiser, you as an agency, don't want to wait a full year to run this analysis again. Next month, you can re-upload that data, and within a few clicks, you can have the same exact results. And if the ROI is still holding, great. If the ROI is not holding, that's when you have an alternative model to look on and change course quickly. Instead of giving your clients or your business partners the wrong advice, you can potentially say, hey, something is off. Maybe the market conditions changed. Maybe the models are not as good as we thought they were. And very quickly have a better recommendation that can save the day. There's more to the platform. I invite you, if you like what you have, what you've seen so far, please request a demo. We actually have a link for you to request a demo if you click on that. But before that, let's share the results of the poll and see what people are using. All right, so there is quite a bit of mix between Robyn, PyMC, and Meridian, and there are some strong StarterQED users, and then there's others. I'll be very interested to see what other models people are using. But Marcel, maybe back to you.
Yeah, thank you. And it's indeed nice to see this, Paul, and I would say the wide variation. And maybe a question for Professor Pauwels. Do you feel that the market is moving to consolidation in time, or do we always see in time that the numerous approaches will stay? So what is your thinking on that?
Yeah, this is very much like Scott Brinker bets against his own instinct every year that we have less instead of more marketing analytics firms around, right? And he has always been wrong in the fact that they have been exploding still. So I see two things kind of going on at the same time. And I had something very similar to kind of, what Phil was saying about in-house versus out-of-house. So you see that really kind of big companies, that they're very happy to experiment with different approaches, and also kind of are very open to the newest things. That is one of the reasons that explains the lack of consolidation. What I see kind of this as a wonderful opportunity for smaller companies. So the way that MMM Labs is organized, it gives you a very efficient view on things that maybe your larger competitor needs a whole in-house team to really work well. In my experience, also smaller companies are much faster of acting on the new advice of MMMs, so that also gives you a very kind of good, a good advantage, a more nimbler advantage. In terms of consolidation of the different models, I mean, so as Gabriel said, I have worked with all of them, and I see different advantages and disadvantages, and it really depends on your context and specialization and your market. So I don't predict any big consolidation in that sense.
No, I think I agree with you on that. People will always want to try out the latest innovations, and they will keep on going.
Yeah.
And I think that's the good thing of the multi-engine approach, where you can make them very quickly accessible for the users, but not needed to change the whole workflow. So that's
Exactly.
indeed a strength. Hey, what I would want to do is I want to go to the questions that came in. They're already coming in quite a number of questions. I'm not sure if we can answer them all, but let's see how far we come. One of the first questions that came in was related to the main use cases of multi-engine modeling and maybe specifically MMM labs. So Phil, can you answer that question?
Yes, of course. Yeah. So it's a good question. I think there are potentially a few different real use cases for this in practice. The kind of main use case where this multi-engine approach really excels is if you're genuinely open-minded at the start of a new project or engagement, for example, and really don't know which way to go. Then having this approach to be able to try all the different engines, compare them side by side, see which works best, and then make a decision is absolutely perfect. I think there'll be maybe more common use case is that you might already have a preferred method, but then sense checking and validating versus other approaches can provide a lot of reassurance to do that sense check, the validation, and just build confidence, assuming that they align. If they don't align, then that can potentially open up some areas for exploration if that's highlighting areas of uncertainty that you might have otherwise missed. I think another common use case, certainly that we hear from some of our clients, is that you might have a preferred method, but then a certain stakeholder might ask a question like, oh, I've read this about Meridian, what would Meridian say? And having an easy way to check that within a platform where everything's already set up versus having to spin that up from scratch with a load of specialized coding just makes that much quicker, much more efficient to kind of answer that question. And I think there's also a use case for sure, which is maybe not using the multi-engine benefit so much, but the fact that MMM Labs offers a really accessible no-code way to use the open source platforms. Because if you're comparing configuration, so different choices of different variables that are in the model with different prior settings, to be able to do that side by side within a nice UI where everything's kind of calculated for you can save a huge amount of manual work. So I think, there's quite a few different ones depending on your situation. Don't know if anyone else has got anything else to add to that.
I think it was quite comprehensive, Phil. So thank you for that. So when looking at the questions, I also see some questions on the application itself. So I think Gabriel, these are for you. And one of the questions that came in is around feature selection and whether that's included. So should you as a user, or can you as a user already upfront before the modeling starts select which variables to choose, or does the system also make use of that and make sense to say like, okay, these are the ones that should be included and these are not? So can you explain more on that, Gabriel?
So that's a really good question. And this is a feature of some of the models. They do it automatically. Robyn, for example, does feature selections through regularizations. So it can shrink a potential variable to 0. PyMC does Bayesian shrinkage, as well as Meridian. And the user also has control. So when you have all the variables, you can deselect some of them that you don't think are correct, or you can group variables. You say, we think Facebook and Google, they're going to be called digital, and model them as a single unit, not as separate. So both the user as well as the model do this feature selection. I've been hearing from other customers that they want to see it more prominently, where there's some kind of stepwise regression initially, and it recommends a group of variables to use. So yeah, it is available both in the models as well as in manual mode. And there'll be a new feature coming called the model search to recommend a certain set of features.
All right, thank you, Gabriel.
The other thing to remember about that is, while we didn't have time to go through all these details, you can easily build multiple configurations that are similar and may contain different combinations of variables. And then when you go to run the model, you can run it against multiple configurations at once and compare the results. So there are kind of different flavors of helping with variable selection, because of course that is a key, that is probably the most important part of building the model. Hopefully that makes sense.
Yeah, thank you. Then I have another question from related, I would say, to MMM Lab specifically, and that is related to the output data set. So one of the attendees is asking like, hey, is there a single output data set developed, or do I just get multiple data sets out of it differently for each modeling engine?
I can take that. So the platform is built to compare all the models or hone in on a single technique, and you can go into the ROIs, the response curves, the optimization. But we know our users like Excel, so we created a special feature. Actually, thanks to Brian, he told me that users want to use Excel. So let's create a single output for a single model to download in Excel, and you can do a lot with it. You can pivot, you can summarize. Or you can download all of them as well. So that's available within the platform natively now.
All right, Gabriel, thank you. One other question is, how are updates handled across engines? I think we already spoke about using marketing mix modeling to update frequently, not wait at least 6 months or 12 months, which I think is all about operational efficiency, which is nowadays, of course, very important. And the question specifically is like, hey, how are these updates handled within in a multi-engine approach? Because you have maybe a preferred model, but then new data comes in. Should you still try out all the other ones? So who wants to provide an answer on that?
I mean, I can take it. This is where when I showed you guys the priors, when you set the coefficient bounds, when you set the adstock transformation and the saturations, I don't want to oversell, but this is where since we have the previous models, we can auto load the previous models into the priors. So that way the new ones don't deviate. And you can do two things. You can run it as a configuration with the previous priors, or you can run it as a new configuration with like a fresh start, and you can compare. And if the models are the same, that means the model initially was correct.
All right, thank you, Gabriel. Then I get a nice, provocative question, which is good to mention here as well. So why bother with multi-engine? Isn't setting up the right model structure not the most important thing? And does MMM Labs or a multi-engine approach help with that? So this is more about, does it prevail the modeling structure? So maybe, Koen, is this an answer? Is this a question you can answer?
See, I mean, I would also say, why bother with putting up a model at all, right? You already have your hunch or your instinct or your experience. And the thing is that very often kind of, if you ever have a certain model, directionally it may be right, just like your instinct may be right? You know, to increase or decrease something, but different models quantify this very differently. So the more you want to optimize, to get more precise, and also then to have different ways to see how things went wrong. So this is marketing, right? So marketing is the most difficult job in any company because it's about the future and it depends on consumers, competitors, everything. So the models will never be exactly right once you implement them in practice. And then how do you learn? If you only have one model, then you can, maybe tweak some inputs, ad hoc, which is typically not a good idea for the future, right? Because you're overfitting. If you had several, you'd be like, hey, isn't this interesting? This other model that we didn't select in the multi-engine last time, actually was better in this particular context to deliver. And if we would have used that one, it would have been easier. And so you can come up with these kind of postmortems much faster, and so institute more learning in your organization throughout. Gabriel?
You're on mute.
I think it goes back to the same idea that initially in the 80s, that's where you set up the structure with the econometric modeling. And do you know why that's done? Because if you don't have the right structure, the model's actually going to give you incorrect results. So what these models now have done, so they're so advanced, some of them will say, despite the wrong structure, we will shrink the variable down to zero. The variable has no effect. So look, it is important to set up the right structure. If you help the model with the right structure, it will give you better results. But we're also guarding that there will be missing variables and you may not know about it. You might say you think you have the right structure, but then you realize, oh, actually, there is a multiplicative effect or interaction I forgot about to include. And you don't want to end up with the wrong results. Because if you, like Professor Koen, if you said, if you already have your hunch, why do you need the model to begin with? And if you already think that you have the right structure, you think that any model will just pick up on the right results, but that's not true. So that's what I would say, is that always compare. Brian?
Even beyond the different modeling algorithms, we all, I mean, when I say we all of us, like all of us who build models for a living, we always put a lot of thought into that structure, but we don't necessarily know with certainty what the ideal structure is. And once we start looking at the data, we often realize there are problems with the raw data itself that warrant changing the structure. So even if you were to decide that you were only going to use PyMC or Robyn, the platform allows you to build multiple structures very quickly, estimate the model with the different structures, and compare the results very quickly. So, that's also a benefit of the platform.
All right, thank you, Brian. And I think there are a lot of questions that somehow related to this topic, so I'll skip those because they're just phrased differently. So I'll go to a completely different topic in this case. And somebody is asking like, hey, if I have already an MMM solution in place, what would a transition to multi-engine realistically mean, both in terms of time, disruption, and in the end, cost, because time is money. So how do we look at it? Because you have a certain, truth in your organization, and you want to switch. So who wants to answer that question? Brian, Phil, do you have an idea on that?
I mean, I'll take a quick stab. I mean, it can often be tricky to make any change that's going to revise an answer you've given in the past. And the bigger the organization, the more scale, the more people involved, the harder that becomes. But at the same time, the point of this is to uncover opportunities for growth. Like the point is to decide what can we change. So I think the specific advantage to multi-engine is that, you're not just comparing old versus new. You're comparing 5 or 6 versions of new and looking for which business findings are consistent and which aren't.
All right, thank you, Brian. I think this is also, given the time, our last question. There are more questions out there, which we will answer separately to the attendees. I think there are good questions there, but we will follow up on that later. So this also brings us to the end of this webinar. So thank you all for attending this webinar. Also, a special thanks to our speakers and a special thank to Professor Dr. Koen Pauwels. We hope that this webinar was insightful. We also hoped that we showed you the benefits of a multi-engine modeling approach. And if you like to know more, please reach out to us. If you also want to have a full demo of MMM Labs, also please reach out to us. You can use the QR code. You can go to our website and book an appointment. So thank you all for today, and take care, and we'll hopefully speak soon.
Thanks much.
Bye-bye. Thank you.
Thanks, everyone.